Epik Mellon podcast, conversations with the real humans behind broadband networks, cybersecurity, and the future of communications. Brought to you by QA Cafe. In this episode, my longtime friend and partner in crime at the Broadband Forum, John Blackford and I talk about the dichotomy of standards and open source software and why soccer is the world's most popular sport. Hello, everyone. Welcome to the Epik Mellon podcast. I'm your host, Jason Wallace. I have a guest in the office with me, which is really strange. Somebody that doesn't work for QA Cafe that's here with me. This is John Blackford. He's a very, very good friend of mine who has been in standards with me for about 20 years.
It has been 20 years of that. Yeah.
And I'll get into why it is that he's sitting next to me right now and why he happens to be in my office in a minute. But it's very cool. And so I think, this is basically like the not counting people who are normally in the office. This is
Right.
the second live in-person one that we've been able to do, which is really cool. So my usual stuff that I'm going to say before we get started, obviously, Epik Mellon is funded entirely by QA Cafe. And so the opinions expressed by myself or my guests don't reflect those of QA Cafe or its leadership. And the same goes for CommScope, I assume.
Yes.
Who John works for. And since we are fully funded by QA Cafe, I like to give a little spiel about 3 products that we offer at QA Cafe. The first is CD Router. CD Router is the industry standard test solution for broadband gateways, Wi-Fi routers, and other customer premises equipment. CD Router contains thousands of fully automated test cases designed by network experts, covering feature validation, stability certification, and performance all in one. Moreover, QA Cafe's world-class support team acts as an extension of your own, helping you understand the technologies and build better products overall. CloudCheck is, wow. I'm not even going to edit that. Play along, everybody. Our second product is called CloudCheck, and CloudCheck is the way to make network packet captures an easy and useful part of your cybersecurity workflows. CloudCheck helps you work on tough issues together without passing large trace files, losing data, or risking security leaks of valuable information. And it helps entry-level analysts learn from your senior experts, curate best practices, and standardize operating procedures around packet captures. And lastly, QA Cafe's Passport is a fully automated solution for testing the connectivity and interoperability of IoT and smart home devices. Testing with Passport is as simple as connecting your device, selecting tests, and getting clear pass-fail results with full log data and packet captures to find and resolve bugs before they end up as a bad review of your product on Amazon. To find out more about CD Routers, CloudCheck, and Passport, visit us at www.qacafe.com. So, John is here because we've been here all week. And the world that we live in is extremely complicated in terms of how it is that we know people and why we know them and why we're even sitting here right now.
Right.
And that has to do with where I used to work, what they used to do, where it happens to be in relation to QA Cafe's offices now, why it is that we decided to be at that location this whole week. But before I get into any of that, John, I wanted to talk to you about how you got started, just because, I feel like that whole story has gotten kind of, I don't want to say that we got it lost, but it's been a long time, and a lot has happened in that time in terms of the companies that you ended up working for.
Yeah.
And as we'll discuss, how, in our industry, people get bought by other people, but we're all still doing the same job. So how did you get started? Even if it was just coming right out of school, because were you CS?
I was a computer science major in school. And I first started off at EDS, a consulting company. And then after a while, moved over to a startup company. I just wanted the faster paced lifestyle when I was young, and I was loving the startup company.
Was it faster paced?
Oh yeah. It was. So that startup company got bought out by another company that got bought out. There was a time we got bought out twice in 6 months. It was crazy. Yeah, it was crazy. So it ended up being Siemens that I was working for, and that's where I started going into standards. The first one was kind of Telemanagement Forum, TMF as they're now called. And then started going into Broadband Forum because we had a product at that time that was just doing remote management of the network, the access network.
Right.
This is old school.
Was it all SNMP?
Yeah, a lot of it was SNMP and some other technologies that were kind of used then. But we kept getting these questions about, what about managing the devices in the home, which was unheard of 25 years ago.
Right.
Yeah.
For a number of reasons. Right.
Yeah.
Most notably, I mean, that the landscape was different in terms of, we were all buying our own. Well, first of all, gateways didn't exist at one point.
Right.
They were just modems that were bridging data.
Right.
And then there was that, and it's been retail for a long time, and there wasn't really the concept of having operators have control over that stuff. Right?
Yeah, exactly.
So long story short, I know that we've talked about this a lot on the show. The standards group that I am the most involved in, that John is involved in, is called the Broadband Forum.
Yeah.
And the protocol that we work on, or have worked on in the past, the most was called TR629, and it is a device management protocol. So it is designed for an operator to be able to onboard you as a subscriber using your router as the focal point for all of this, right? And control all kinds of stuff about your experience. And that has since evolved into the new protocol that we use called USB. Anyway, continue.
So while I worked at Siemens, we started then going to DSL Forum, which was what it was called before. The name got changed to Broadband Forum. And at a certain point early in the life cycle of TR69, I switched from Siemens to Two-Wire. So from Two-Wire then was acquired by Pace, which was acquired by Eris, which was acquired by CommScope. So it's been a ride. That was 5 or 6 years probably. It took a while. Yeah.
Right. Yeah. Because Two-Wire was around for quite a while.
Right? Oh yeah. Yeah.
Which is funny that they called themselves that, because it was always tying themselves to DSL, right?
Yes, exactly. Yeah.
So that's why they're not around anymore. No, just kidding. Two-Wire guys, we love you.
Yeah, back when I started Two-Wire, they were doing everything on their own. Yeah. They were even doing their own chip designs and making their own chips.
Oh, for back when Silicon Valley was actually Silicon Valley.
Yeah. So.
Wow.
Yeah.
Wow.
They did everything start to finish. Yeah. Very different than
amazing. Yeah. Wait, so you started off doing this management stuff.
Yeah.
Like how so what was the startup that you were working for? Did that have anything to do with it?
Yeah. The startup that I went to work for was called MMD Multimedia Development Corporation. It was a small company that was owned by these two guys that worked at DSC together. And they quit DSC to go start up their own company. And they had a lot of friends in the business, the telco business. They had a few that worked at what was then called MCI WorldCom. And so they were kind of a custom development shop for MCI WorldCom, doing all kinds of telco related software, getting into remote management and all that kind of stuff. So, yeah.
I was just telling my wife that we were recording. Cool. All right. So when you went to work for Siemens, that was already but it was entirely a suite of network management, right? But you got into it from how did you seek that out, or did they seek you out?
Well, so Siemens was one of those acquisitions that came across for the startup company, MMD Corp, got bought out by another company I can't remember the name of anymore, which got bought out by another company that got bought out by Siemens. So it was kind of this was right when the dot-com bubble was bursting.
Right.
When all these acquisitions happened. So I think that maybe Siemens didn't quite realize that the bubble was bursting and maybe was regretting the purchase after a while.
Right. Well, no, but when I met you, you were working for Siemens.
Yeah.
And that was when
TR69 was brand new.
Right.
Been out for maybe a year or so.
Yeah.
And we had our own ACS at the time.
Yeah.
And it was one of those fresh pieces of software that everyone was trying to figure out how to actually make it work. Because the spec was written way different than we write specs today.
Yeah.
The it was basically just one big long Word document with no clear requirements anywhere in there. So you had to kind of read the whole document again and again and again.
Yeah.
Just to figure out what you were supposed to be doing.
Yeah. That's, man. And it was built on like a hodgepodge of many different things, right?
Yeah.
So like it imported a lot of legacy from other protocols, right?
Yeah.
That people decided to use. No, it's most notably UPnP, right?
That's where all the data model stuff came from. Yeah.
Right.
But it was built on XML and SOAP. But TR69 completely did something that was anti what HTML and SOAP was supposed to be. And with a single communication session, the switching ownership between the session, between the first part of the conversation and the last part of the conversation, which just, if you were to look at the actual underlying protocols and standards you're using, SOAP, it's like, this doesn't make sense.
They weren't meant for that at all.
No, it doesn't make sense.
It was like,
right.
Right. No, but it's funny because I get why it was done that way.
Yeah.
Because nothing else was really around.
Right.
And now we have all sorts of other different ways of transmitting messages over the internet. Right.
Yeah.
Because even back then, chat was very rudimentary.
Yes.
Right. Which is effectively what you're looking for in that kind of communication.
Right. Funny thing is that one of the early drafts of what was being proposed for TR69 was going to use something that was called BEEP as the underlying protocol. It was a bidirectional protocol, so it would have been way better. But I'm guessing the reason that it was told, no, we can't do that, is because nobody had ever heard of it.
Right.
It's like, no, we have to use like HTML.
Was it a standard?
Yeah. Yeah, there's an RFC out there for it, I'm sure.
So it wasn't like Stomp where it started off as a
right. No, it wasn't.
Perfect. Interesting.
Yeah. Stomp's a different beast all on its own.
Well, no, and it's good because it's one of the things that I think we can talk about is that over time, like the standards world has changed dramatically, right?
Oh yeah.
And just the way that we do things, right? I was talking to Tim Winters about this on the first episode, just about how the ITF has changed. And they're doing stuff the way that we do stuff, where it's like, it's using Git and using rather than these monolithic documents that get passed around and right. But anyway, so standards becoming more agile. But not only that, like the open source world, kind of when TR69 started, it wasn't an open source world.
Not very big at all. No.
Like. There wasn't at all. And it's funny because people are always like, why didn't you guys ever make an open source version of TR69? It's like, well, that wasn't a thing.
Right. But there were a few versions that they claimed to be open source. Right. Like Easy CWP was one, I think.
Well, right.
Yeah.
Well, there were people who made it, but it was years later. It was 8 years later.
Yeah. Right. Yeah.
Yeah. Anyway, so I bring up Stomp as that interesting case because that was something that we decided to incorporate into the new standard, which is called USP or TR369, right? And it's also a device management protocol, but does a whole bunch of other things quite well, I must say. And so that's why we're here in the office right now, because this week we did a huge summit on everything that people have done so far in development. We heard from a bunch of operators, which was very cool. And then there was also a plug fest. And for those of you who have never heard of plug fests, and I don't think I've talked about them before, it's when a bunch of engineers all come to the same place. In this case, the University of New Hampshire Interoperability Laboratory, where I used to work, and where many of us did, who are out here at QA Cafe. And all the engineers get together in a room and they try out the protocol, right?
Yeah.
And so that kind of helps us figure out what wasn't clear and what isn't. And we haven't done one in so long because of the pandemic and for a number of other reasons. So this was the first one that we've done in quite a while. And as a result, we're all here together.
Well, this is also the first one we've done since we actually versioned the protocol. So
you're right.
So that's an interesting. I heard rumors of some issues that people were having between different versions of between the CPE and the controllers.
Glad.
So hopefully we get some of that as feedback. Yeah.
No. So I was when we incorporate the new standards USP, we're here because we just did a blog post and stuff like that. One of the protocols we picked to transmit USP messages in the initial version of the standard, and still in there, is called Stomp.
Mhm.
Now, Stomp is not a standardized protocol. It was written right originally as an open source project. Right?
Yeah, I believe so.
Yeah. And so that world exists out there for us. And we've run into it a couple times in a couple places with a couple of different solutions that are out there. And it's kind of weird. It's weird. Right? It's different.
It's different. There's a document that explains how Stomp works, but it's not backed by like the IETF or anything like that.
Right.
Like QTT is.
Right.
But it's a very simplistic document to read through, and it's actually a pretty simple protocol.
Oh, it's almost like simple as in the name.
Yes. Don't ask me what the rest of Stomp.
I think it's the simple text oriented messaging protocol.
That sounds right. It does.
Stomp, which is a great backronym, and my kudos to you guys for naming it that. That was awesome. We almost named USP. Damn,
we did. That was mine, I think. Yeah, I love that. You wanted us.
Yeah,
that's right.
Yeah, connected user services platform. So it's interesting to me, we don't have to go down too much down this road, but like, one of the things that we run into as a standards group, right, is the protocols have what is called a data model, and the data model is a way of describing the capabilities of the software and hardware that you're trying to manage, right? Data models as a concept is a much more higher level computer science concept than just the way that I'm talking about it now, right? So I'm going to use language that's very specific to what we know, but it's a much more general idea. So the data model, is very powerful because it's been evolving constantly over time, right?
Yeah.
Constantly. We're always adding new stuff, right? So it is made such that somebody who is using the protocols or who's building a device that can be managed by the protocols can be like, here's what I can do. And because the data model is standardized, you up there, Mr. Controller, already know how to deal with it, right? And so that's stuff like, this is network device management, right? So it's all the network interfaces, it's all of the things, it's all the applications that you would expect a networking device to have, like firewalls and all those stuff. The biggest thing is all of the Wi-Fi KPIs, right?
So big,
big, and that keeps getting updated
always growing
all the time. And part of the reason is because that is and has been for the recent and foreseeable future the biggest pain point that the management protocol is needed for.
Yeah, right? And it's always evolving too.
Yeah,
Wi-Fi 7 is just around the corner, and we've been lucky enough recently to actually have a really good relationship with Wi-Fi Alliance, who are totally the experts in the area, to help us evolve that data model such that we're putting the right things in there.
Right.
Yeah.
And actually, that's a great example of what I was going to talk about. Is like when we have that collaboration with standards bodies that are talking the same language as standards bodies, it gets in there well, and it's done right. But we've run into situations where there's people who don't necessarily understand how standards work, or maybe they're like afraid to get involved and I don't really know, right? And they go through and they plow through and develop a bunch of stuff.
Yeah.
Right. And for example, you can make extensions to the data model that are your own thing.
Yeah.
They're called vendor extensions, right?
And sometimes it makes sense.
And sometimes it does make sense if it's like something that
very custom,
right. But I've run into like the situation where you have open source projects that sort of want to plow ahead. Yeah. And they're like, no, we need this solution right now. And they'll do something and then contribute it to us. And we're like, oh, wait a minute. And they're like, well, we already did it. And it's like, well, don't do that.
Exactly. Yes.
And so anyway, that's not a world that existed before, right?
Right.
In the earlier versions of protocols. Of course, still people wanted to do their own thing, but it was never sort of I don't know. Well, I guess we still had it back then where it's like people I find it interesting that it doesn't occur to people to talk to us first.
Let's check with the people that originally created the data model that we're working on.
Well, I mean, look at TR69. There's an entire, and it's happening already for USB. There's an entire culture out there of TR69 developers and solutions that have never talked to the brand.
Okay.
Never.
Yeah.
Entire forums of developers tell us.
Yeah. Yep.
Yeah.
But one of the projects that we've created, speaking of open source and USP, is that we created the Open Broadband USP agent as an open source project.
Right.
And we have had some good luck getting people asking questions about USP, about that open source project.
Oh, yeah, through those channels, right? Through
GitHub.
Yeah.
And so it's been really good. I mean, there's sometimes it's people just asking, how do you do this in the actual open source project? Right. But sometimes it's, have you implemented this yet? Pointing to a part of the data model or part of the actual specification.
Right.
So it's like, that's encouraging. I mean, they're out there reading this stuff and now they're asking questions.
Right.
Instead of just going off and doing it on their own.
And we'll be like, no. Oh, we are now. I do enjoy how much that has come up too.
Yeah.
It's along the same lines of what I was saying. It's like, it's not, I guess people don't understand how to engage standards bodies, and maybe us in particular. And I feel like we're a little different, right?
Yeah.
But like, they'll come to us like, is it okay if we do this? And we're like, that's a great idea. You should come and contribute it. You don't have to wait for us to do it.
No. And that's a lot of times what we say for the open broadband USP agent. It's like, we are going to plan on doing that, but maybe we're not going to get to it for another 6 months or 9 months. So if you want to bring that in, would be more than what.
I'm so glad you brought that up, because that's sort of been the other thing that I think I've always been disillusioned to at this point, is that forget our roles, right? Forget standards and what we're talking about right now. The open source community in general and the entire idea of it was based on the idea that is supposed to happen.
Yes.
Right.
Yeah.
But it doesn't.
Yeah.
Think of how many open source projects are out there that people just expect somebody to be doing work on it.
Yeah.
Right. Rather than,
I mean, a lot of times you may get like some bug fixes submitted to you, stuff like that. But feature development, it's a lot less common.
Yeah.
Yeah. I mean, there's definitely some open source projects out there that thrive and do have that.
Well, generally the ones that have been taken over by somebody.
Sometimes, yeah.
It's, I don't know. And you have the examples. You have the Red Hat's the best example. Right?
Oh yeah.
Where it's like, yes, Linux is open source, but who the hell wants to do that? Luckily, there's a team of people that you can pay to do that, right?
Yes.
Yeah. And so it's not for things go in waves, right? So it's like the promise of open source, and everybody was super excited that there was going to be software that the world collaborated on together. And it was like, oh well, really not everybody's going to do that, and everybody's going to try to treat it as if it's free, right? And really what they want is, when they hear open source, they want free. Right?
Yeah.
And then it goes back up to, oh wait, no, it costs money to integrate things. Maybe we'll go back to paying something to do that.
I don't quite see it as quite exactly even on both the up and the downswing, but I think it's it starts very big and then eventually it kind of slowly comes down, and you'll eventually kind of normalize down to a line.
Yeah.
I mean, I've seen that, like, if you look back in like computers and how people buy computers and stuff like that, it started off with, we have big supercomputers and then just dumb terminals that everyone can log into.
I'm so glad.
And then it was no. Everyone needs their own massive computer on their own desk. And then it swings back the other way. It's like, no, maybe it's not quite a dumb terminal. Maybe it's got a little bit of smarts, but most of the intelligence in the cloud. It just keeps swinging back and forth.
Right. Yeah. Which is what we've seen happen with CPE, right?
Oh yeah. Yeah.
So what we're working on right now is the fact that, there was a push a while back for the router that you use in your house to be really dumb, right? And to do basically nothing and have everything done in the cloud with, and have it be part of the entire software-defined networking infrastructure and all this other stuff. And it turns out that everything went in the total opposite direction. And now we have really, really powerful routers with a whole bunch of computing capacity that do all kinds of crazy stuff.
Yeah. We're talking about like putting applications on the routers now.
Yeah.
But at some point in the future, you'll start saying, okay, well, maybe that's not the right thing to do. You want maybe put it back into the cloud. So do we want the more of those applications to live in the cloud and less to be on the actual gateway itself?
Yeah. I wonder why. I wonder why there is that cycle. Because you see it with everything. We see it with
I think it's people push too far. It's like it's a great idea, and then they push too far, and then the rest of the industry has to pull them back into alignment a little.
Right.
But then it swings the other way with momentum.
Yeah. No, right. No, it totally is. That's totally what it is. Because the two other like more human examples that I can think of are, for one, remote work.
Yeah.
Right.
Yes.
Right. And how like that's actually the other end of a trough when like outsourcing was a really, really big thing. Right. And they were like, oh, well, maybe that's not the best idea because it's really hard to coordinate. Yeah. We have the tools to do that now, but it was, it's hard to do. And then we went back. And then everybody's like, oh, pandemic, let's all go back to remote work, and now people are like, oh, well, maybe that wasn't the best idea. Yeah. But you're right. It's normalizing. Yeah. Right? Where now it's kind of both. Yeah. Right. The other example I always think of is open concept offices. Right. Or shared workspaces. Yeah. And everybody's like, this is great. And then eventually it was like, no, it's not.
Then they try to find a kind of a happy medium where there's some open and then some closed.
Right. Yeah. I like ours out there because it's open, but we are so far apart from each other. Yeah. That when COVID hit, we were here and we were like, oh, everybody's already 8 feet away from each other.
Nice.
Yeah. It's interesting how it does that. And there's always seems to be sort of collective amnesia about it.
Yes. Yeah, don't learn from the past ones. We'll just keep barreling forward. Yeah.
I really like that you brought up the cloud example though, because I always think back to Tron.
Okay.
And how that was like in the 80s, right? It was the master control program was a giant mainframe.
Right.
And the way that people interacted with it was going to a dumb terminal.
Yes.
Right.
Yeah.
It was the entire plot of the movie.
Yeah.
Right.
Yeah. Well, back when I was in college, we had a VAX, which was pre Linux. I mean, there's Unix around, but it was not quite. I can't remember exactly what it was running, but the lab and the computer room just had dumb terminals. They're all connected to that very small supercomputer. Right. It wasn't a supercomputer, but it was just
for the time. It was very super.
But yeah, all the accounts were on it, and you just had a dumb terminal, and but it just moved immediately into, workstations.
Right. Yeah. Right. And did that work how it works in the movies? But it was like, I'm going to make basically a resource request, and to do a thing, and it's going to prioritize it with all the other things that it's trying to do.
Kind of. I think so. In the back end, it did.
Yeah.
Because I remember in college, one of our classes was there was a project to write a multi-threaded project. And that was a major disaster because some of the students basically were forking off threads in like an endless loop and took the machine down.
We're going to take this sucker down right now. See, that could have been the plot. How are we? It's out of control. How are we going to take it down? Make an infinite fork loop.
The lab administrator was not happy. She was passionate.
Well, I mean, it's kind of guaranteed to happen eventually. You have a bunch of people experiment.
Yes.
So yeah, speaking of college, I mean, you have your unsaid side career as a soccer player, yeah.
Oh, that's a long time ago. Was it? I don't play anymore.
Oh, I know, but
I did. I played in college and I played after college for like 10, 15 years.
Yeah. So did you play on like the college team?
I did. Nice. Yeah, I played 3 years of college as a goalkeeper, mostly on JV. because I'm not very tall. But so they never really wanted to play me up in the varsity team because our team was actually really good. We were a Division III school, so we weren't NCAA.
What school was it?
Midwestern State University
Yeah.
in Wichita Falls, Texas. We had a great soccer team. We were like 1 point ranked fourth in the nation for our division.
Oh,
school division.
shit.
Yeah. Mm-hmm.
Wow.
Yeah, they went to nationals a couple years. Yeah. So I got to play in one varsity game because the coach got mad at the goalkeeper. He thought he let in a goal that he thought he should have stopped.
It wasn't like a movie. It wasn't this dramatic thing where like he gets super injured or like.
No, he got upset at the goalkeeper because he thought he let in an easy goal. And so I got to play the second half, and it was intense because we were playing a really top team. I think the top 10 team in the nation. And we ended up losing the game 1-0, but I didn't let any goals in. So I did my job.
Oh, so it was that one goal that he let in?
Yep.
Wow.
Yeah.
That's a story.
Yeah.
Huh. No, but you've been following it now too, and I always like. It's funny not to say that I'm a bandwagon kind of guy, but I generally am. Like I like excitement when everybody else gets excited, and so like when the U.S. soccer team when people are paying more attention to actual football, that's what amazes me is how removed we are in the U.S. from how seriously this game is taken in the rest of the world. Like it's the game of the world, and we don't really play it for some reason.
We have our own professional league.
Yeah.
And it's, Austin actually, I live in Austin, Texas, and Austin just got their first professional sports team in its history. This is 3 years ago. So this is the third season. And it's a soccer team.
Cool.
No baseball, no football, no basketball.
So how does that look at what layer are they? Right.
It's top layer. I mean, it's the professional league.
Yeah.
It's called the MLS, Major League Soccer. But there's, Austin is kind of unique because while it is the capital of Texas, it is by no means the largest city in Texas. Dallas, Fort Worth, Houston, and San Antonio are all bigger.
Right.
And that's where all the professional sports teams are, those cities.
Right.
So it's kind of hard to justify, I guess, a fourth football team or something like that in the state.
I mean, Texas is
it's huge.
So it's like.
But we got the soccer team, and the first season not very good, but the second season they were exceptional. They made the playoffs, and they went, I think, to the semifinals in the playoffs. So
cool.
Yeah, they did well. This year, not so much.
So how does that work? I'm sorry for asking like super ignorant questions about this. How does it work when it comes to choosing the U.S. team in the World Cup?
Oh, I don't actually know. I've always heard there was quite a bit of politics around it.
Oh, really?
Yeah. Like when I grew up, because there's always the under 18 teams, the under 21 teams, their national teams that are supposed to be feeders into the actual national team, the men's national team. And, it was always very difficult to understand how you got on those teams, how you tried out for them. I'm sure, if you're the most talented person in the specific area that they're looking for you.
Right.
But there's so many different leagues around the country that it's got to be very difficult for them to actually keep track of every single player everywhere.
Well, so when do they choose? Like, how long does the World Cup team? How long are they a team when they go compete? Like,
yeah, because I mean, they have sections of time where they have friendlies and there's kind of national team time. But they don't really get to play as a team all that much because all the players are playing in professional leagues everywhere around the world.
Right.
Like the U.S. men's national team has people in the U.S. League and the British Premier League and the German leagues, and I'm sure in the French leagues as well. So all these countries all around the world have their own professional leagues.
Interesting.
Yeah.
Interesting.
That's why a lot of times when you'll see the national teams play, you'll see players from other countries like, hugging each other after the game, or congratulating them, or
Right.
whatever,
Because
they all know each other. They play against each other all
Right.
around the world.
Interesting.
Yeah.
Interesting. So the World Cup is really kind of more like a specialized Olympics than it is, because it's not like the best team out of the U.S. leagues stays a team and becomes the U.S. team.
No, it's more like the Olympics in that regard. Yeah.
Interesting.
Yeah.
Yeah.
But the Europeans kind of have a little bit of an advantage, because there's also the Euro Cup that happens every 4 years on the 2 off years of the World Cup.
Right.
And so that's, again, a national team structure where it's pretty much mostly European teams, and I think they bring in Iceland as well.
Mhm.
But they have another tournament that's kind of like the World Cup, but just for those countries.
Huh.
So, I mean, we all over, you have various different kind of cups like that. South America has their own version of it as well. We have one in North America and down into Central America. But it's not quite of the stature of the European one.
Right. In terms of popularity.
Yeah.
And ergo money.
Yeah. Right. Yeah.
Which is, it's to bring things back to our jobs. Like that's been sort of this, to coin a phrase, UK, the sticky wicket. When it comes to all operators being able to switch over and become sort of what they are today, where it's just media consumption of all kinds, that's all going over IP, right? And basically it's our job to build those systems that deliver those things. But it's like live sports the size of things like the World Cup have always been the thing that's like the last like major use case that is really hard.
Yeah.
Right. Because how do you're basically like distributing this one show to like millions of people over the network.
And the other aspect of that is that you also have like up to like 100,000 fans all crowded into a very small place, where they're all wanting to use their mobile devices.
About this with Lucy, and the episode came out this week.
Oh, okay.
Right.
Yeah.
And so he does it's a Hemina Networks, and they do Wi-Fi mapping, right?
Okay.
So like they have a bunch of tools that it's like heat mapping, but it's also like he'll go in and be like, okay, this is your setup and here's your environment, and he has all these modeling tools. It's like, this is where you need to put your APs and these are the channels.
Okay.
All that stuff, right?
Right.
And he was talking about how in stadiums it's totally bizarre.
Yeah.
Because of the meatbag factor.
Right. Again,
when you have 100,000 bags of mostly water,
it causes a little interference.
Yeah. So he was saying what they do. They actually put an AP under almost every seat.
Wow.
Right.
Interesting. Okay.
Like Oprah style. Like
yeah.
But if there was no people in the stadium, you're what did he say? It's like your shitty Samsung phone can hear the AP that's on the other side of the thing, right?
Right.
No one is there.
Yeah.
Yeah. No, it's a super difficult problem.
Yeah.
It's interesting how we've kind of come down to always having mobile as a backup, and it seems to be more reliable than everything else. Yeah, I imagine in certain areas like that, it's still not.
Yeah. I've been to football games where at the UT where there's no way you're getting a signal out, or if like at concerts and music venues and stuff like that, where you have so many people crowded into a small space and everyone's trying to use the bandwidth. You're like, nope, I got nothing.
Yeah. Or what was it when the iPhone first came out and AT&T was like, and they're like, no, the network can't handle everybody having an iPhone. Sorry. And I think they got kind of in trouble for it. Not in trouble for it, but it was bad press, But it was like, it's a really difficult situation because it's not like you can tell people no when there's this wildly popular, life-changing new technology that's coming out. Everybody, man, it's crazy. Yeah. All right. So what was that? There was one other thing I was going to talk about along those lines. Oh, back to what I was talking to UC.
Yeah.
One of the things that came up was management systems,
Mhm.
right? Because when he's working, it's mostly enterprise
Yeah.
campus management systems.
Yeah.
Of those guys, the Meraki's of the world, and everything that are building.
Mhm.
That's their thing.
Yeah.
That's what they do. And versus us, we're dealing with
Yeah.
very heterogeneous Wi-Fi networks and right and interoperable management systems.
Yes.
And the thing that came up was where is the line between how smart Wi-Fi can get on its own versus how much device management can fix the problem,
Mhm.
and that there's kind of a balance between the two.
Yeah. Well, CommScope does have a section called Ruckus that is that kind of enterprise Wi-Fi. They do a lot of stadiums and campuses and stuff like that as well. And we've had discussions with them. And the interesting thing is that they're building a Wi-Fi device that is nowhere near what we are building for the home. They put a lot more tech and gadgets in that and have a lot more access to data that you don't typically get in the, quite honestly, less expensive Wi-Fi chips that you put into a home gateway.
Oh, interesting.
So when we went to ask them about, okay, what are the main things, you're experts in Wi-Fi, what are the main things we should be looking for Wi-Fi performance? They started giving us all this information. And we went back to our home gateway team. They're like, we don't have any. Oh, wow. You can't get that.
It's true. And so it's weird how dependent we are.
Yeah.
Because it came up with the power stuff.
Yeah.
Right. Like because basically people want to build gateways that use less power, but also like are informed about all kinds of other power management things.
Yeah.
But being able to get that information from the system.
Right. In a home gateway, it requires an extra chip be added.
Yeah.
And the whole point for the home gateways is you want to get the cost down as low as you can.
Because you're selling tens of millions of them.
Exactly. Yeah. For enterprise Wi-Fi, you're selling a couple hundred.
Yeah.
Big deal.
Yeah.
For your home in the home gateway, you're selling a couple million.
Right.
Yeah. Every 10 cents adds up when you're talking about 2 million.
Yeah. That's crazy.
Yeah.
So I wonder if that problem will be solved in a way that doesn't involve having to put all that extra stuff in there. I don't know.
I doubt it, because it's just one of the things that's not on the chip. So because it's not just a way to measure the power being consumed, but the RFPs that I've seen also want you to be able to turn off portions of the device because they're not being used. And this is something that we kind of spoke about earlier this week in our board strategy meeting for Broadband Forum, is they want to be able to say, okay, I can't turn all of Wi-Fi off because everybody has IoT devices in their house that need to use Wi-Fi cameras at night. You want those to be on and recording and stuff like that if they're outside monitoring your house.
Right.
But what you could do is turn them over to the 2.4 network instead of the 5 gigahertz network and shut down the 5 gigahertz network because it takes more power.
Oh, right.
So
you don't need it at that time.
Yeah.
Right?
Yeah, exactly.
Yeah.
And so there are things that's kind of how the industry is starting to head, is to be smart about your power consumption, be able to turn things on and off based on usage and time of day and stuff like that.
Right. And the containerization thing, I assume, helps that too, because now all sorts of functions can be turned off separately, right?
Yeah. Right. Yeah. Yep.
Well, I think we've been here. It's been a very long week. I don't know if people understand, at least in the Broadband Forum, when we go and do our actual standards meetings, they're very long. They go from 8 a.m. to 6 p.m. every single day.
Yes.
So it starts to wear on your mind. And this week has also been a very long week. So John and I are going to go have a beer now. And
yes, we are.
So thanks, Jude. I appreciate you for coming in.
Yeah, thanks for having me.
Yeah. And I'll say my usual stuff. Please subscribe. Hit that YouTube button if you're watching on YouTube. Subscribe using your favorite podcast mechanisms that are out there. That all helps. Comment and like it. The algorithms love that stuff. And above all, own the nerdy things you love and have fun doing them.